Welcome to today's Explainer. Today we're jumping right into Chapter 3, which gives us a brief overview of Python. But I want you to think of Python as more than just a programming language. Think of it like a massive construction project. Together, we're going to look at this language block by block, starting straight from the foundation and working our way up to the complex structures that make software actually function.
Now, before we get overly technical, let's talk about the human element behind the code. Python was created back in 1991 by Guido van Rossum, and his philosophy on structure, it's pretty fascinating. He actually asked, "Don't you hate code that's not properly indented?" Making it part of the syntax guarantees that all code is properly indented. He literally built the language to force us to be neat, organized, and clean. It sets a beautifully relatable tone for our journey today. Good code isn't just about complex math, it's about clear, readable structure.
Okay, let's take a quick look at our roadmap for today. First, welcome to Python. Second, code building blocks. Third, operators and expressions. Fourth, talking to your program. And finally, making decisions and looping.
All right, Section 1. Welcome to Python. Your first steps with the interpreter.
So, before we can build absolutely anything, we need an environment to actually run our code, right? In Python, there are basically two main ways to execute your code, using the interpreter, and they serve very different real-world needs. First, we have interactive mode. This is for instant execution. You type a single line, hit enter, and bam, you get a result right away. It's incredibly convenient for quick tests. But the catch is, you can't save your statements here for later. That is exactly where script mode comes in. Script mode is where you write out all your instructions, save them in a file, and then execute the entire program whenever you want. So the rule of thumb? Use interactive to test and script mode to actually save your hard work.
If you ever seen those three little arrows sitting on the left side of a terminal, that's the Python prompt. It's basically the interpreter sitting there telling you, "Hey, I'm ready, give me an instruction." You can type some basic math, like 1 plus 2, and it instantly spits out 3. Or you can add text together, like hello plus world, and it just gives you hello world. It's immediate, interactive feedback, which is super cool.
Moving right along to Section 2. Code building blocks, the vocabulary of Python. Just like any spoken language, whether it's English or Spanish, Python has a very strict vocabulary and grammar that we absolutely have to learn in order to build our programs correctly. First up, we've got keywords. Python has a specific set of reserved words, things like false, class, return, true, and death. The computer has essentially claimed these words strictly for itself to perform specific tasks. And because Python is super case sensitive, these keywords must be written exactly as they appear. You can't use these reserved words for anything else in your program. They belong completely to Python.
But wait, if Python totally owns the keywords, how do we name our own stuff? Well, that brings us to identifiers. An identifier is simply a custom name that you create to label a variable, a function, or any other entity in your program. This is a vital distinction to make here. Keywords are locked down and reserved by Python, but identifiers, those are your own custom labels. For example, if you wanted to store a student's score, you might create an identifier and name it something like total_marks. Now, whatever data you are actually labeling with your identifier, it's going to fall into a specific data type. Literally every single value in Python belongs to a data type. So, why does this matter? Well, Python needs to know exactly what kind of information you're dealing with because that dictates how the data operates. Python has to know if your data is a number, a string of text, or a dictionary. I mean, you can't perform division on a word, right? The data type tells the interpreter exactly what is mathematically and logically possible.
Next up is Section 3, Operators and Expressions, the math and logic engine.
Think of operators as the mortar that connects our data blocks together. Now, you're probably already familiar with standard math operators like plus and minus, but Python has some surprising and frankly really fun unique operators. Take a look at the modulus operator, that's the percent sign. It divides two numbers but only returns the remainder. Then there's floor division, which is the double slash. If you divide 5 by 2 using floor division, it completely removes the decimal and just gives you 2. We also have the exponent operator, the double asterisk, to raise a base to a power. And of course, relational operators like the double equals sign, which checks if two values are exactly the same, or the exclamation mark equals, which means not equal to.
Let's actually see how this builds up step by step when we combine operators into an expression. It's literally just like the algebra you learned in school. Python follows a super strict order of operations. In step 1, Python looks at the expression and attacks the parentheses first, 8.0 plus 3.0. That brings us right to step 2, where the parentheses have become 11.0. Next, Python knows it needs to handle division before addition, so in step 3, 15 divided by 4 becomes 3.75. Finally, in step 4, it adds them together to get 14.75. It breaks down complex math like a really satisfying logical puzzle.
Okay, section 4, talking to your program. This covers input, output, and functions.
You know, a program isn't super useful if it just sits there calculating silently in the background. We need to make it interactive. But before we look at specific tools for that, let me pose a question directly to you. If you are building a massive program, how do you avoid writing the exact same complex block of code twice, or 10 times, or even 100 times?
The answer to that? Functions. A function is just a set of grouped instructions bundled under a specific name that performs a reusable task. Imagine you have a program that needs to calculate compound interest in multiple different places. Instead of typing out that huge mathematical formula every single time, you define a function once, maybe you call it calc_comp_int, and write the formula inside it. From then on, you just reuse it forever by simply calling its name. It's a massive time saver.
Now, the absolutely crucial point here is that Python actually comes preloaded with dozens of built-in functions, and they're neatly chunked into categories so you don't have to build everything from scratch. You've got input and output functions like print to display text or input to actually ask the user a question. You have data type conversion functions to turn text into integers. You have math functions to easily find the maximum or minimum of a set of numbers. Python essentially gives you a fully stocked toolbox right out of the gate.
And that brings us to section 5, making decisions and looping. This is how we direct the flow of the program.
This is where things get really cool, because we're teaching our program how to make actual decisions. The first way we control flow is the if, elif, else cascade. This lets the program choose different paths based on certain conditions. Python reads these conditions chronologically. It checks the if statement first. If that's false, it drops down to the elif, which just stands for else if. What's totally vital to understand here is that Python stops checking the exact moment it finds a true condition. It executes that specific indented block of code and then completely terminates the statement, skipping everything else. It is a highly efficient cascading filter.
The second major way we control the flow of our program is through loops. Loops are honestly just a great way to force the computer to do all the repetitive, boring work for us. We have two main types to look at. First, the for loop. You use this when you know exactly how many times you want to repeat something. It iterates over a strict, exhausted range of values. Then we have the while loop. This one executes repeatedly as long as a specific condition remains true. It doesn't actually know how many times it's going to run, it just keeps spinning and spinning until the condition finally becomes false.
Wow, we have covered a ton of ground today, from simple interpreters to custom variables, powerful operators, functions, and loops. But before we wrap up this explainer, I want to leave you with a provocative thought straight from our chapter's case study. Imagine taking these exact building blocks and applying them to a massive real-world project. How would you design a student management information system? How would you use variables to record personal details, math operators to compute final grades, and loops to track daily attendance for an entire school? Think about the logical flow of that. That is the true power of Python, taking simple foundational blocks and building systems that can literally change the world. Thanks for hanging out with me today, and keep building.